Hello, everyone, and welcome to week 12 of our course and part 3 in our series on market models. This week, we'll be jumping ahead in the text to chapter 26, which is the oligopoly market structure. I did, however, want to take a quick moment to encourage you to read through the material of chapter 25 if you have time, which is monopolistic competition. This material will not be on our homework, it will not be on our unit exams, and it will not be on our final exam. However, it will help you with your final project, and the material and the concepts from chapter 25 are especially applicable if you're a business major. With that out of the way, let's jump right into chapter 26, which is the oligopoly. Oligopoly is defined as a market structure in which there are few sellers. Each seller knows that the other seller will react to changes in price, quantity, or quality. What an oligopoly market structure creates is strategic dependence, where changes in advertising, price, quality, or quantity will be countered by the other firms within the oligopoly's industry. So, why do oligopolies occur? The main reason oligopolies occur are mergers. And there are two types of mergers that the text is going to go over. The first is a vertical merger. And in a vertical merger, an input or an output firm will buy each other. Let me give you an example. Let's say Home Depot decides to purchase their main supplier of wood, or vice versa, the wood firm decides to purchase Home Depot. This would be an example of a vertical merger. The other merger, as you might have guessed, is a horizontal merger. A horizontal merger occurs when the joining of firms producing the same product merge into the same firm. An example of this happening was when Disney, who owns Disney Plus, decided to purchase Hulu. They're both streaming services, and that would be an example of the second type of merger, horizontal mergers. How do we measure the concentration of an industry within an oligopoly market structure? The text is going to go over two different ways, and the homework will also have you work through problems with each different way. The first is a simple concentration ratio. And an example of a concentration ratio might be that the top 5 firms within an industry control 80% of that given industry. The second is called HHI, which simply stands for the Herfindahl-Hirschman Index, the two gentlemen that made this index. It is the sum squared percentage of all of the sales within a given industry. If you have questions on the homework on how to work through either HHI or the concentration ratio, let me know. I'll typically work through a few in this given week. How do oligopoly firms operate? Well, they operate under strategic games. And there is a whole study devoted to these strategic games that's called game theory. I love game theory. I wish I could teach a whole course on game theory. I almost got my graduate degree in game theory. It's a really, really interesting study that can not only be applied to oligopoly firms, but can be applied to war or even really, really small micro interactions between two different individuals. There's several different types of strategic games or game theory that the text goes over. The first is a cooperative game. And in a cooperative game, both parties within our oligopoly structure cooperate with each other because they realize that they are both mutually benefiting from this cooperation. Another name for this cooperation is they've formed a cartel. A really common example of this cooperative game might occur within your town, where you pass two gas stations that are right across the street from one another. You might notice that these two gas stations often have the exact same price for gas because they're cooperating, because they realize that mutual beneficial relationship benefits them both. The second type of game is a non-cooperative game. And this is when one of the parties within our oligopoly realizes that the price change, quality change, or quantity change is going to benefit them in the long run. The third and final type of game that the text goes over is a zero-sum game. And in a zero-sum game, we're looking at a multi-step progression where at first they might adjust their prices down, and that adjustment in prices down will lead to an increase within market share. However, that increase in market share ends up not benefiting their profit from the start of the game. So in the end, they end up with zero-sum game. The most famous type of game theory that's talked about often is this idea of the prisoner's dilemma, where they take these oligopoly structures and apply it to a very, very micro level between two different prisoners. And in this prisoner's dilemma, the officers ask suspected murderers or criminals if they committed a crime. If they confess to the crime, of course, they receive a lower sentence, or they're even let out of jail with no time served. If they don't confess to the crime, they get a higher sentence. However, in some cases, it makes sense for them not to confess. Let me go through one example of two prospective criminals using this prisoner's dilemma system. We have Gertrude here on the top, represented by blue. Sally is also suspected of the crime and is represented here in orange. You'll see within our axis, we have confess and don't confess for Gertrude, and confess and don't confess here for Sally. If both Sally and Gertrude confess, they both receive 5 years in prison. If one of them confesses and the other doesn't, the one that confesses, of course, gets 0 years in prison, while the individual that didn't confess will receive 10 years. If they both don't confess, they receive 2 years. However, if you go through the situation for one individual person, you'll see that there's an equilibrium to this prisoner dilemma's game. Let me show you. If we look at Gertrude, who is represented in blue, if she confesses, she will either receive 5 years if Sally also confesses, or 0 years if Sally decides not to confess. However, if she does not confess, she's either faced with 10 years or 2 years. And because Gertrude's scenario is going to be better off whether or not Sally decides to confess, because if she confesses, then we can conclude Gertrude will confess. Sally also has the same conclusions to her confession or not confession. Therefore, our Nash equilibrium in this prisoner's dilemma will be right here in the top right corner, and we would suspect that both Gertrude and Sally will confess, and they'll both receive 5 years in prison. As you can see, game theory is kind of fun, going through the different scenarios that firm B will make in reaction to firm A's decision. The homework will walk you through some of these micro examples like the prisoner's dilemma and some more macro examples like firm decisions. As always, if you have any questions in regard to the homework or the text in chapter 26, let me know. If not, we'll talk next week. Thanks.